Hello, my name is Keith Stein. I'm the program chair for the regional meeting taking place here in St. Louis. And I'd like to welcome everyone to our ACS Governance and Roundtable event. We have a very special event today. We have a panel discussion and roundtable on the role of chemistry in society. And before I get started with introducing and turning the event over to Bassam Shakashiri, who will be leading the discussion and conversation here, I'd like to introduce the ACS board members who are here in attendance, and they all welcome your approaching them to ask them questions about ACS events and ACS policies. We have George Bodner, who is the Director for District 2. We have Peter Dorhut, who is the Director for District 5. And we have Marinda Lee Wu, who was a Director at Large and is here with us today. And I'm very pleased to introduce Professor Bassam Shakashiri, our ACS President-elect, who will start off today's roundtable on the role of chemistry in society.
Thank you very much, Keith. Good afternoon, everyone, and welcome to this special occasion, which I hope at future regional meetings will not be special. It'll be part of what we always do at regional meetings, at governance sessions. I want to thank the panel before we got started for agreeing to be here. They have some enriching and enlightening remarks to share with us. But I want to invite everyone in the audience to participate in the conversation after the panel members finish with their remarks. And I'll tell you now what the ground rules are. I will be making the first presentation, both from my perspective as President-elect of the ACS. I want to share with you some of the initiatives that, some of the new initiatives that ACS will be undertaking in 2012 and beyond. And then I'll be followed by Chancellor Mark Wrighton, and then we'll be followed by Chancellor Vaughn Vandegrift, and then batting cleanup. We have to use language like that now, right? Will be Susan Fitzpatrick. Each panelist has about 8 to 10 minutes. At the 8-minute mark, I'm going to indicate to the panelists using this device that they have 2 minutes to go. And when 10 minutes are up, I have a prearranged for the stage trapdoor to open, and the panelists will disappear if they haven't finished. And then we'll have open discussion. So please take notes, collect your thoughts, be thoughtful. This session is an experiment. We all like to do experiments. It's not a chemistry experiment, it's a social science experiment. And so I want to thank you also for being here. I want to thank you for your support and participation in all ACS activities. And I want to invite you to suggest modifications, big changes, new ideas for ACS to undertake. Because ACS is not only the largest scientific organization in the world, it is the premier science organization in the world. And it is so because of the members, because of the people who belong to it. And you should have high expectations of ACS. And I say to you in return, ACS has high expectations of you. So let me paraphrase a statement that's about 50 years old now, almost 60 years old. Ask not what ACS can do for you, ask what you can do for ACS. And that is the reason that that is the major reason that I have agreed to be a candidate for ACS president, and I'm very fortunate to be president-elect, and I look forward to serving you and serving with you, not only ACS, but science and society. So I'm going to begin my remarks by sharing some of the questions that the panel may choose to address and ask you to think about them too. What are the grand challenges in chemistry today? What are the profound scientific questions that we are addressing today? And are we prepared and ready to address these questions? Are we ready? Are we prepared to address them? It's one thing to identify them. It's what we're going to do about them that is perhaps more important. Are we likely to succeed in convincing society to support us in addressing these challenges? You know, we do research because as a human species, we are curious. We ask questions. We like to know the answers to those questions. And the more answers we get, the more we realize how little we know. But in pursuing our research activities, we depend on the generosity of the general public. And so it's very important for us to try to be convincing, not only to ourselves, but to society, to support us in our endeavors to meet those challenges. So here's kind of a rhetorical question. Why should anyone pursue a career in the chemical sciences? Why are you, the young people, pursuing careers in the chemical sciences? I ask this question so that we affirm our convictions about the importance of those explorations that we all engage in the chemical sciences. What are the employment prospects in the chemical sciences? What should we do to raise the public awareness of the importance of chemistry in daily life? Chemistry, we all like to say, is the central science. I like to say it is the central science, but it's also the familiar science. In fact, I love to say it is the science of the familiar. Everything around us is made of chemicals. And that's why we must focus on our science being the science of what is around us and what we are familiar with. So let me go through these ideas in headline form here and be more than happy to engage in conversation with you today and after today about such ideas. All right, so I have selected as a theme for 2012, advancing chemistry, communicating chemistry. Advancing chemistry, communicating chemistry. And I'd like to remind everyone what the mission statement of the American Chemical Society is. You can read it, it's on the screen, and forgive me for reading it. You know how it is sometimes a presenter puts a slide up on the screen, proceeds to read it. It's an insult to the audience. You can read it. I don't mean to insult you, but I want to share with you these emphases about what this mission statement says. It says, to advance the broader chemistry enterprise and its practitioners for the benefit of Earth and its people. Such a profound statement. I only wish I had written it myself. The ACS vision is improving people's lives through the transforming power of chemistry. That word right there, transforming. Transformations are very, very important. This is what happens in graduate school. You begin as a graduate student, and somewhere along the line, halfway, about halfway, you are transformed into a scientist. Transformations are very, very important. So, I've selected 4 initiatives. I'll just share them with you in headline form. Next year is the sesquicentennial of the Land Grant Act. You know that the Land Grant Act has transformed America. ACS will mark this sesquicentennial at the national meetings in San Diego and in Philadelphia, as well as, I hope, at regional meetings, by affirming our mission and by showcasing the accomplishments of chemistry, chemical scientists, and ACS. I'm about to send a letter to every department chair in chemistry, chemical engineering, biochemistry, material science, asking them to look back 150 years and identify accomplishments in those departments. You know, they weren't even called by the names we have them now. Identify accomplishments from the past 150 years, post them on a website, tell people in the community, immediate community, about them, and ACS is going to select the nuggets from those and put them on the ACS website as we retrospectively look at what we have done. But to me, it is important to look back, but more important to look forward. So I want ACS and all of us to be prospective. Before you are prospective, you have to know who you are, how you got there, and where you want to go. Who we are. Advance the broader chemistry enterprise and its practitioners for the benefit of Earth and its people. So the second initiative that I have is the appointment of a blue ribbon panel to examine the purposes of graduate education in the chemical sciences. Examine the purposes of graduate education in the chemical sciences. I'll say a few more things about it in a moment. The third initiative is to help the public understand the science of climate change. Not the politics of climate change, not the economics of climate change, the science of climate change. So that before I have a conversation with my neighbor about the science of climate change, I want to make sure that I myself know what that science is. I want to make sure I know what a greenhouse gas is. What is the greenhouse effect? Why is it that every molecule with 3 atoms or more in the gaseous phase is a greenhouse gas? What are the scientific characteristics and properties of those molecules that make them a greenhouse gas? And are all greenhouse gases equally effective in climate change? You know, in our jargon, we talk about having a dipole moment in the molecule, right? We have selection rules, right? We're fairly good about talking with each other about this, but we have to develop ways to talk intelligently with our neighbors about the science of climate change. For goodness sake, Arrhenius talked about this and predicted within half a degree over a century ago what the change in temperature is. And yet here we are, as members of a science organization, as members of an educational organization, as members of a learned society, wanting to share our knowledge because of our responsibility, share our knowledge with the public at large. The fourth initiative is to explore the possibility of setting up an ACS high school teacher fellowships program. So you'll be hearing more about this, about all of them and others shortly. So the Presidential Commission on Graduate Education in the Chemical Science, the main charge to the Commission, I issued this charge earlier this week. What are the purposes of graduate education in the chemical sciences? Why do we have graduate education programs in the chemical sciences? Has the German model served us well? And is it appropriate for the 21st century? The second question, what steps should be taken to ensure that they, meaning the purposes, address important societal issues? Important societal issues, you go back to that mission statement, as well as the needs and aspirations of graduate students. And I'm happy to share with you the names of this commission. And in particular, I'm very grateful to Chancellor Mark Crichton to be a member and a leader in this commission. Everyone on this commission is a very distinguished person and brings to the table very powerful, thoughtful ideas. And what's important is that they be effective in developing alternative models for us to consider in graduate education in the chemical sciences. Why do we start with graduate education? Because before too long you have to think of where the graduate students come from. So this will segue into undergraduate education in the future. And again, where do the undergraduates come from? From pre-college. So the starting point and the targeted assignment for this group is to look at graduate education in the chemical sciences. There'll be listening sessions at future meetings. There'll be all kinds of interactions. You'll be hearing more about this in CNE News and elsewhere. So Mark, thank you for being on this commission. I'm very grateful to you. So I said the themes are advancing chemistry, communicating chemistry. How do we advance chemistry? We have advancement through research, through education, through innovation. Society consists, in my book, of two sectors: the science-rich sector and the science-poor sector. Who's in the science-rich sector? Colleges and universities, the national laboratories, parts of industry. Who's in the science-poor sector? Everyone else. It is incumbent upon us, those of us who are in the science-rich sector, to communicate with the science-poor sector. I want you for a moment to think about what is happening politically in our country and around the world, and think about this division. Just skip the word science and skip the word in both of these. There are problems that we fail because of the widening gap between those of us who are informed, educated, and knowledgeable and the rest of society. This gap between the science-rich sector and the science-poor sector is widening at a very alarming rate to the detriment of both sectors, and we should do something about it. So how do we do it? Well, before we get to the how do we do it, we should decide what we want to do. So in science, there are scientifically competent people, those of us who are in science. We have scientific expertise. But what we want the general public to be is science literate. We want literacy in science. We want an appreciation of science without a deep understanding of physics, chemistry, and biology. Because we want to have science be looked up to and appreciated. Science and technology are the engines that drive our economy. Yet most people don't understand how these scientific and technological advances come about. We must work at science literacy. If you look at the program that you have for this meeting, you'll see in the abstracts that we have provided some more elaboration about this. What are the elements of communication? So advancing chemistry, communicating chemistry. The elements of communications include inform, engage, educate. You get to the stage where you advocate, and some of us are very highly interested in persuading others to act according to the convictions that we have. There are other elements, but those are the ones that I'm focusing on right now. And it's very important to have connections, to make proper connections with the audiences that we talk to, as this panel will be doing very shortly. Make connections. We don't want to have impedance problems. We want to have good connections as we try to share our values and our convictions, not only with each other, as we do very well at scientific meetings like this one, but with the public at large. Science is vital to democracy. And for us to communicate our values as scientists, I dare say, not only our values, you know, gangs have values. Our virtues as learned individuals and learned groups is very, very important. Someone said it much better than me. He said, public sentiment is everything. With public sentiment, nothing can fail. Without it, nothing can succeed. It's very important for us to communicate with the public. Otherwise, we become so isolated from them, and we risk having them lop us off and forget about us. Einstein said, most of the fundamental ideas of science are essentially simple. Well, maybe to Einstein they were simple, but he said, most of the fundamental ideas of science are essentially simple and may, as a rule, be expressed in language comprehensible to everyone. You think about that. Think about the science that you're doing. Think about communicating your science to people who are not scientists. I want to very briefly describe to you a program at the Wisconsin Initiative for Science Literacy, which is my research program in Madison, where we ask graduate students to include in their PhD thesis a chapter explaining their thesis work to their mother, to their grandfather, to their families, to members of society. And for everyone who does this, we give a $500 cash award. So those of you who are thinking about going to graduate school, you might want to come to Wisconsin. And if you include in your thesis, it says here the first 10 will get it. We're way beyond 10 now. This is just a partial incentive for us to think about communicating our science in language that's understood by others. So, Color, Light, Vision, and Perception is the title of my latest volume, Chemical Demonstrations. And I'm very pleased, as a token of appreciation, to present one to each of our panelists. So Mark, this is yours. It's autographed. Susan, this is yours. Tom, this is yours. And some of you in the audience, if you look in your lunchbox, you'll find a little note that says you have won a prize. And so look carefully in your lunchbox, and you can claim your prize. You can claim your prize at the registration desk. This prize includes a copy of this volume that just came out. This is the cover of it. And I use, as you know, chemistry demonstrations to engage audiences. And I'd like to show you in my last slide, as you look with me at the slide, I'd like to show you why it is important to engage people. That's why. That's why. That's why. That's why. You just look at their faces and see for yourselves the importance of engagement. And it's more important to think about what's going to happen after engagement takes place. So, invite you to visit my website if you haven't been there already. And there's how you get to my website. So those are my opening remarks for this. They are a mix of my statement to you as ACS President-elect, and now and a statement about the topics that we have selected for this panel. And now it's my great pleasure and honor to present to you the first, yeah, we can close this off. The first panelist. And rather than take time to repeat what is in the program here, you can look at the panelists' bios right here. I'd just like to introduce very briefly to you the Chancellor at St. Louis University, a very distinguished chemist. And if time allows, maybe he'll tell you why he went to chemistry, but I know that story too. So please welcome Mark Wrighton.
Good afternoon, everyone. It's a pleasure to be here. And no, I haven't changed positions. I remain the Chancellor of Washington University in St. Louis.
I just asked Mark if he'd hear my confession.
Father Biondi continues to lead a great institution. Dr. Shakashiri, I really appreciate this special volume. In an earlier era, I was known as Magic Mark, and I really enjoy chemical demonstrations myself and can affirm the importance of this kind of experience, as in my college experience, it was a beginning course in chemistry that led me to declare chemistry as my major. And through the years that followed, I have to say I became even more convinced that chemistry would be a great opportunity for me, and I've been extraordinarily well rewarded in every way imaginable. In connection with today's program, I was arrested by the very first question that we were supposed to respond to, and that being, what are the grand challenges of chemistry? In an earlier time, perhaps there would be those who would respect me for a knowledge base that would enable me to give some response to such a question. I haven't actually been doing chemistry in the last 16 or 17 years, so I have to say I'm not so well qualified to comment on the grand challenges of chemistry. But let me say that I believe that chemistry represents an area of intellectual inquiry that will enable you to address the grand challenges that face society. Chemistry is a science that is so vitally important, and I believe that those who are going to become engaged in the field of chemistry will have an opportunity to literally change the future. I believe that we face several tremendous challenges, and some of what we see ahead will depend on advances in chemistry. Perhaps the greatest challenge is the need to provide abundant energy at an affordable cost without adverse effect on the environment. Some would say that clean water is another grand challenge that faces the world. I don't disagree, but I believe that if you have abundant energy at an affordable cost that's provided without adverse consequence on the environment, you'll be able to deal more effectively with the water challenge. To put this challenge in perspective, today the world is powered with about 15 terawatts. With the growth in population and the growth in economic development of countries like China and India, we're going to expand the use of energy inevitably over the next 40 years by another 15 terawatts. That's a lot of energy. It's hard for the public to come to grips with just how much energy that is. What does it mean? What is a terawatt? 1 terawatt, of course, 10 to the 12th watts. That's 1,000 1 gigawatt nuclear power plants. Let's assume that we wanted to provide the extra energy we're going to need in the next 40 years with nuclear power. I'm not advocating that we pursue that course, but let me just indicate what it would mean if we did it. It would mean 14,000 1 gigawatt nuclear power plants. The United States, by the way, hasn't built a new nuclear power plant in decades. And it would be very difficult to build a new one now in a country like Japan. Even so, think about the implications. In rough terms, a 1 gigawatt nuclear power plant would require an investment of the order of $10 billion. So to build all these nuclear power plants would be of the order of $150 trillion. I used to think that was a pretty big number until I heard about the national debt. But I think you can agree that that is a huge amount of capital. Why would one even entertain the notion that you might pursue the nuclear option to this extent? Part of the rationale will be that nuclear power actually provides a very competitive price for electricity. Indeed, the levelized cost of electricity from nuclear power in the United States is competitive with the levelized cost of electricity from coal-fired power plants. But nuclear power does not involve significant emissions of carbon dioxide as we see from coal-fired power plants. We need an energy option, or perhaps better put, a set of options to provide the energy we need at an affordable price without adverse consequence on the environment. I lay that challenge before you as one of the most significant, not of the next 5 years, but of the century. This is a very long-term problem. We're going to be using fossil fuels for a good long while to come. Coal is ubiquitous, and oil is relatively abundant and in some areas relatively easy to access. Some would say we don't have time. We really don't have time to begin pursuing the options and implementing the best of those. But I put before you that as one of the most important challenges that chemists can address. Accompanying the growing population and the growing development in the large countries will be the need for more food. As the economies grow, it's also the case that the diet changes with greater intensity in the need for agricultural productivity. This is another area where chemists can make a very important contribution. I also lay down the challenge of coming to the ability to produce this material world that we enjoy from resources other than petroleum, perhaps coal, perhaps plants. What new chemical feedstocks would be in greater abundance and potentially more useful? At Washington University, third challenge, we are engaged in a very large effort to improve human health. Chemists play a vital role in advancing medicine, and this remains one of the greatest challenges, from diagnostics to clinical activities. We at Washington University, for example, were involved very early on in the development of positron emission tomography, an outgrowth of an investment in nuclear chemistry. Not so much support today for nuclear chemistry. Should there be more? What priority should we set in the future? One thing we can be sure of is that the advance of human health will be more and more important as the world's affluence continues to grow. Finally, let me comment on this matter of advanced education in the chemical sciences. I'm pleased to be a part of the commission that has been appointed by the President-elect of the American Chemical Society. And for those who have earned PhDs, as I have, you might reflect on your experience and ask, is it the best experience that would prepare you for academia, national laboratories, or work in industry? I've come to the conclusion that significant improvements can be made. One of the areas where I believe we need to make an investment is in the area of international experiences. The rest of the world is advancing rapidly, and if it were ever true, it is certainly not true today, that the best science is only done in the United States. Great things are happening all across the globe, and we need to invest time and effort to understand what's taking place in other countries. An international experience will be an important component to prepare a person for work in either academia or in industry, as so many of the great corporations and aspiring corporations will want to take advantage of what is being learned in other countries, what can be manufactured in other countries, and what can be sold in other countries. So that's one component that I will be advancing as we discuss the nature of doctoral education in the chemical sciences. Thank you very much for listening to these remarks, and I look forward to engaging you in discussion afterwards.
Thank you. Thank you very much, Chancellor Wrighton of Washington University. My apologies, Mark. Next panelist is the Chancellor of SIU Edwardsville, and please welcome Dr. Vaughn Vandegrift.
Thank you. And I also thank you for the book. I began my career teaching high school chemistry in the 60s. I really could have benefited from that. I'll make sure it gets used today. To the question about challenges in chemistry, Chancellor Wrighton has already identified some areas of societal needs. I'll move quickly through those so I could get to another aspect of it that I took. But certainly energy, health, safety, and food and agricultural needs are going to be very important in our challenges for chemists. But I'd like to talk a little bit about the challenges that Dr. Shakashiri has gotten to a little bit in terms of actually performing the science, some of the challenges that are out there to enable us to perform it effectively, and educating for those who would be chemists and would be in the discipline. And I'd start with something Dr. Shakashiri mentioned, the public perception of chemistry. And this then, of course, spills into the area of scientific literacy. And I'd like to suggest that at a time when we're in a very different economic situation from what we've been in the past, that we might expand the science of literacy, or the notion of scientific literacy or chemical literacy, a little bit beyond that to science or chemistry as a way of knowing. I think one thing that our colleagues in the liberal arts have done is to provide students a sense of the value of the liberal arts by pointing out the critical thinking that's done in history or in English or in the other areas of the liberal arts. Why not think of chemistry as liberal art? Why not value chemistry as a discipline to be studied for the benefits it provides one in terms of the critical thinking, the ways of knowing that it brings to life? Now, before you say, well, we already have an employment problem, that's my second thing. Yes, there are employment. You only have to pick up an issue of C&E News now to know that there continue to be employment problems. But this is the way the liberal arts continued, was by addressing their employment problems as talking about the importance of the liberal arts as ways of knowing. Well, I think that there are different ways of knowing, but the chemistry, the value of science as a way of knowing is every bit as valuable. And to suggest that someone who has an undergraduate degree in chemistry must simply move into the field of chemistry and continue in that area denies what many of us have already done with their careers. I began as a chemist, now I'm a chancellor. I certainly use the approaches, the techniques, the ways of thinking that I learned as a chemist, but I'm not doing chemistry. So I think it's very important for us as chemists, for the ACS, to consider extending the scientific literacy to including, chemistry as a way of knowing. Now then people will say, well, then you're going to attract more people into chemistry, and we already don't have enough jobs to go around for chemists. So what does that mean for new graduates? Well, as I said before, it doesn't necessarily mean that someone who gets an undergraduate degree in chemistry has to be a chemist. But there are things that the ACS can do to address this. So one, I have public perception of chemistry. Second, I have employment issues. Third would be STEM education itself. Now, the ACS and the NSF are doing a lot about STEM education, and it's very important that we continue to emphasize what things we can do for students to be more broadly trained and educated and focus on science, technology, engineering, and mathematics. So I think that that's going to be a challenge that will continue, and I think ACS has already begun to address that in a lot of areas. The fourth thing I have that's a challenge for us performing the science and for society is the outsourcing of chemical services. There's been a lot in C&E News recently about how, as the pharmaceutical industry has downsized, that they've outsourced a lot of their chemical services, and typically, Dr. Wright mentioned this, the notion that the science is being performed well in other areas of the world is very important here, because they are able to perform these services more cheaply. So we've had lots of pharmaceutical services and synthetic services and so forth moving to other countries. So I think supporting the infrastructure, supporting businesses, and encouraging whatever statutes, policies, whatever is required to ensure that the innovation takes place here. And that gets to the idea of the fact that our immigration laws do not always enable us to retain in the United States, very creative scientists who could innovate here. Now, here again, the argument is, well, we have American citizens, and they pay taxes, and we have to provide jobs for them. But what about someone who can become an American citizen who is creative and innovative, and what will they bring to our society? So I don't think our immigration laws are serving us in the way they should. Bottom line is competition is good, more bright people getting graduate degrees who stay here in America, who want to stay here, who can contribute here and do well. In the end, that's got to be good for the country. That's the way I see it. That's another issue. Maintaining federal support for chemical research, very important that ACS continue to encourage more NSF support for funding for chemical research. I don't know if you're counting, but I think this is the 7th. But traditional barriers to interdisciplinary research, and I think we've done a lot about that, but if these advances in energy and health and safety and agriculture and food, chemistry and those areas are going to come about, we're going to have to continue to break down the barriers. It's happened somewhat in medicine and in and chemistry and biology, but it needs to happen more in other areas. Have I used my 10 minutes? Yes, okay. Well, I'll stop there and leave the questions, any other remarks for questions that may come later. Thank you.
Thank you, Vaughn. And, you know, I haven't had a chance to use this little gadget I have here, so they're both very well timed, and I appreciate that. Our panelist next is Dr. Susan Fitzpatrick, and I'll set your slides up for you. I'm sorry, I should have done that.
While we're doing that, I'll just say how pleased I am to be here and to be included in this panel, and I hope you don't mind that I'm going to stand up. We've been sitting for a while, and I also am going to take this in a little bit of a different direction, so we're going to try to shake this up a little bit and get ready for the discussion. So it's been a long time listening to these talks. It's reminded me that it's been a long time since I was sitting at the console of an NMR spectrometer looking over the Sterling Hall of Chemistry when the sun set in New Haven. And since that time, most of my work has been in, well, I work for a private foundation, so I fund science, but we also, my own interest is now in recovery from injury to the nervous system. So I'm a little bit of an outsider here. And so I thought the best thing to do would be to give you an outsider's perspective. So while I'm very hopeful that Mark is right and that the energy problem will solve the water problem, I'm pretty concerned about the water problem. And I also think it's interesting, following on what Vaughn said, that while chemists and the field of chemistry have very high regard among the public, the chemical industry does not. And I think part of this is this problem with products from chemistry being seen as damaging to the environment and to the natural world. But anyway, I do not mean to insult your intelligence by reading anything that might be written on my slide. It's only to support my own ability that I might be able to do that. But anyway, I think, there are, in addition to our public water supplies, there are over 15 million US households that rely on private household wells for drinking water. I have a place in the country, and I happen to be one of these 15 million. And if your groundwater is polluted, you're pretty much out of luck because there's no other source for you to get potable water. So I'd like to add that the water challenge is also a grand challenge in addition to the energy challenge, because if it's really going to take us years and years and perhaps a century to solve the energy problem, we can't wait that long for clean water. I don't want to repeat what has already been done by the field of chemistry, so we have this Beyond the Molecular Frontier book, which is a book that came out about 8 or 9 years ago. It was a National Research Council study, and I think they did a really good job of, again, pointing out these issues. Some of the grand challenges for chemistry are this problem of dealing with the impact of chemistry on the natural world. So the energy problem, the climate change problem, the water problem, the chemicals that we are introducing into our bodies through the containers in which the styrofoam cups, the plastic water bottles, the ground water chemicals from fertilizers, from insecticides, and the effect that these are all having. People are concerned about this, and I think this idea of developing a chemistry that is kinder and gentler to the natural world is one of those grand challenges. I think another grand challenge, to get back to Bassam's point about that there being two sectors in the world, I found this very interesting paper that recently came out in Nature Chemistry by C.N.R. Rao that talked about the two faces of chemistry in the developing world. So again, you know, chemistry can promise so much, but it can also, who's it delivering to? I mean, do we all need more glow sticks, more nanotechnology, more and tinier cell phones, when there are people who are struggling every day to get clean water and the basic needs? So how do we get chemistry, the kind of people who go into chemistry, to think about solving those kinds of problems, not just the developed world's problems, but the problems that everyone living in the developing world has to face on a daily basis for survival? So one of the ways I think you do that is that you alter your rewards in favor of solving real problems. So instead of the rewards being, can you get another tiny, incremental, obscure paper published, or can you contribute knowledge that will really advance society? So I think there are three traps that basic science or any kind of a science that's looking for applications against practical problems fall into. And I encounter this almost every day, I said, in the work that I'm most interested in, which is helping individuals who have suffered nervous system damage. So the rewards favor studying the model at the expense of what's being modeled. So in biology, the disease model becomes the focus of the research and not the disease. I'm sure there's a corollary to that in chemistry, where somehow the chemistry problem or the fine details of your chemical model or what it is that you're working on suddenly takes center stage, and the problem that you were actually trying to solve begins to fade into the background as you hoe your row narrower and narrower. The lure of beauty is a powerful attractor away from the mess of reality. The beautifully controlled experiments that we can do in the laboratory and the elegance of research shies away sometimes from the messy reality of the fact that you can't control everything outside of the laboratory, that you can't always anticipate what the unintended consequences of some of our research might be. But I think we have to, if we really want to solve practical problems. And then we often shift from what I call the truly ill to the worried well. So again, in biomedical research, you know, if we can't really cure malignant melanoma, we can work on basal cell carcinoma. We can shift to a problem that's very tractable, it's much more easily solvable, and really in the long run isn't going to make that much of a difference to the lives of people. So there's a tendency to do this because we're very comfortable dealing with problems that yield to our approaches, and we're very reluctant to take on problems that are really difficult and for which we may not have the tools that we need right now to solve. But if we lose our eye on that prize, we wind up failing what I think Bassam is challenging us with, which is, why do we do this? I mean, pure knowledge is beautiful, but if it's true, it should also be applicable to real problems. So I also want to challenge you a little bit today, not so much to worry about what chemistry can bring to society, but chemistry as your own society. And by that I don't mean the ACS, I mean the population of people who consider themselves chemists. Because I think if we're going to have this other kind of chemistry, we may need different kinds of people, or we may need to be encouraging the right kind of people who get frustrated and leave the field. So how relevant is the work that you're doing as a graduate student or an undergraduate or a postdoc in those very, very early days to the dreams and the visions and the goals that maybe first brought you into chemistry? How welcoming is the field? If you don't sort of look like a chemist or fit the social profile of a chemist, how welcome are you? How welcome are your ideas? How welcome are your approaches? And how diverse is chemistry? And by that I just don't mean the classic notion of diversity, men, women, different races and ethnicities, but again, the way of thinking, the way of pursuing a problem, the way of building a career, which may not look like the classic model that we're so used to seeing. And how open are we to multiple entry paths? What if I decided today I want to be a chemist? What's my possibilities? What's my opportunities? What can maybe I could bring to chemistry a wealth of experience from other kinds of knowing that could really benefit the field. But I bet you I would have a very hard time trying to get accepted into a chemistry program. So I think those are some of the questions that I'd like to introduce as kind of challenges. And I just wanted to sort of have you look at some of these things. I mean, so I'm also wearing a different hat. I'm the president-elect of the Association for Women in Science. And, you know, there's these occupational differences between men and women. You know, not surprisingly, most nurses are women, elementary and middle school teachers are women, most engineers are men. What's interesting is that Screen Actors Guild, you know, there's this portion between the roles that go to women, and particularly as women are getting older. Again, I think it gets to this question of what are we willing to welcome and how welcoming are we? But I want to congratulate you, because chemists are actually doing pretty well. The percentage of female chemists increased from 11% in 1985 to 30% in 2009. So you're doing good. You're attracting women and other underrepresented minorities into chemistry. The problem is the numbers are small. I was really surprised to see that the number of doctorates awarded to chemistry was, you know, somewhere around 3,000. I mean, I'm not worried about the fact that we have too few chemists. I think we could use a lot more chemists. I think we could use a lot more people trying to solve these grand challenges that have been laid out to us. But what happens to all those 39% and wonderful numbers of people who earn chemistry degrees when, if you look at the tenure track faculty in the top 50 science departments by discipline, and this was in 2001 and 2002, and I bet you it has not changed significantly from this time. 12% women, 1% African American, 2% Latino, 0.2% Native American, and 90% white. So I think if we're going to need the kind of people who are going to bring diversity of thinking, diversity of thought, diversity of values, and diversity of the kinds of problems we're willing to work on, this isn't going to cut it. So we have to look inwards at the welcoming and who we are willing to offer opportunities to wear this wonderful title of chemist to. Thank you very much.
Thank you, Susan. Now it's time for the audience to participate in the conversation. So I ask you to raise your hand, and I will recognize you. And identify yourself, please, and then keep your remarks short or question short, and the panel will happy to become engaged in what you have to say. So. Research shows there's something called wait time. It takes about 15 to 18 seconds to respond to a question, even when it's a multiple choice question with the answers in front of you. Okay, so I filibustered long enough that there's a question here and then there's a question back there. So start. Art.
Art Language Support State University, just recently retired. I got the impression that the research, for the sake of research, is to be frowned upon in the future. I believe that in the past we've gone upon the basic research to solve problems in today's society. What is your point of view?
Can I answer that?
Whoever wants to answer.
I hope that's not what you took away from my remarks. I don't believe that at all. I think it's very dangerous for scientists to sell their research as only when it's relevant or only when it's practical. But what I did say was that if your research is true, it should be applicable to problems. Doesn't mean you have to apply it. but it should be applicable. I think there is a tendency to do a lot of research, and again, you know, I'm much more familiar with the biomedical sciences, where there is no translational pipeline, which is the term that we like to use, because the information doesn't translate, because it doesn't go anywhere, because it's highly artificial and disconnected from a real problem. So I think, and to sell your research as though you're solving a problem when you're not. So I think there's a difference between blue skies research, working on interesting problems, going where your nose leads you, doing something for the beauty and elegance of it. But if it's true, if what you're doing is inwardly coherent, it should be applicable somewhere. Somebody somewhere is going to take that knowledge and apply it. If you're doing research that is just inward and focused on a highly artificial, highly disconnected problem or disconnected system, it's not going to go anywhere, because there's no place for it to go. So I think those two things are important, and I think there's a lot of the former being done, research that is disconnected from any kind of reality.
Yes.
So my question is, how do you bridge the gap globally between science-rich community and science-poor community? How do you bridge the gap?
Between what two communities? Between what two communities? I'm sorry, I didn't hear that.
Science-rich community and the science poor.
Uh-huh.
Well, in the area of energy and environment, I think Dr. Fitzpatrick was noting that there's a good fraction of the world that doesn't have access to clean water. And in rough terms, 3 billion people, that's half the world's population. And I believe that known technology exists that will make an important difference in the lives of large numbers of people. And connecting the world that actually has access to energy and a degree of affluence, that world can readily connect with the other world through the application and deployment of that technology. It does require helping others learn some science, to learn how these technologies work and how they're to be maintained. But I believe that that is one area that we can work toward, where people with knowledge in science and a willingness to reach out and help educate others in ways that have great practical and immediate consequence, they will learn what's necessary to maintain that technology if it's provided to them.
I just say, I suppose the answer to that question is not a simple one, because we have the science, well, you know, science educated and science poor, so to speak, groups. But I think from the important thing from the standpoint of the ACS and from all of us as scientists and chemists is holistically always to couch what is being done in science as to what the benefit is, or the science behind the benefit, if you will, depending upon how you look at it. You know, for example, you hear now that a lot of parents of this age are not getting their children immunized because they've never seen you know, an outbreak of a disease, so therefore it doesn't exist. You know, they don't understand the value of immunizing the population. So that when somebody shouldn't say, well, you got to get your kid immunized, someone should be explaining why immunization is important. So in everything that the society does and everything that we do as educators that has a science value to it, I think that ought to be communicated at the time that the discussion is made.
Yeah.
Ann Nally, I'm a professor of chemistry in Oklahoma at Cameron University. I was interested to hear your comments about how many PhDs we should have and should we continue educating people in chemistry. I have an excellent suggestion. 2 weeks ago I was in Congress, talking to Congress about continuing support for NSA. As I look around me, we have almost nobody in Congress who was educating in the areas of science. Let's take all those excess PhDs and let's make politicians out of them.
The problem is they're driven by data. Politicians aren't always driven by data.
But they could be.
They could be.
So let's include, as we're training our PhDs, as you guys think about education for the PhD, whether we're doing graduate education, let's include a course in politics in there. Let's train them how to be a good politician. It's something we really, really need. And so if we have all of these excess PhDs that aren't finding jobs, don't go out there and train them all. Let's train them and send them to Congress and change the way Congress operates. Think about it.
Yeah, Peter. Peter.
Peter Gorhout, I'm from the Colorado section. I'm the District 5 Director, and it's hard to follow Ann Nally's comment with anything, so I'm taking a risk here, Ann. One of the things that you pointed out, which I've been a strong advocate for as a dean of the graduate school for 7 years, in terms of graduate education and internationalization of graduate education and graduate students. And I think ACS has an opportunity to consider, like we have to take off of Bassam's quote from John F. Kennedy, we have the Peace Corps, and there are a lot of critical areas within the Peace Corps service, maybe a chemistry corps, and maybe an opportunity to serve not just here in the United States, but serve in a Peace Corps capacity around the globe, and have ACS really promote that service as being a component of either an undergraduate or a graduate career, as a chance to really understand different cultures around the world and how folks understand how to do science and how to apply what we learn.
You know, there is a program that the State Department is now running called Diplomacy of Science Diplomacy, I guess it is, and they are looking for scientists who would be willing to serve in the diplomatic corps. So there are, you know, again, these opportunities that we can do to both reach out to other countries, but I think we also need to think about how we're going to build in-country capacity, and I think this idea of yours would be fantastic, particularly if it had a component where something then was going to stay in the country, where you were transferring knowledge in a way that you could begin to build capacity in country. I think would be great.
Yes, sir. Yes, please.
It seems like a number of you started out in chemistry, but then you transformed onto other career paths. So I have two questions. One is, you know, what is it about chemistries that enabled you to be successful in your current career path? So what skill sets have you learned that you use regularly? And as a corollary of that, for the young scientists in the room, whether they're undergraduates or graduate students, you know, what skill sets should they be looking for to succeed in the career?
Maybe I could take a stab at that. You know, I get asked this question often, and especially by people who are non-scientists. They say, gee, you know, chemistry, a person running a university, how does that happen? And I say, well, first of all, you have to understand that science is not generally a solitary profession. We're all working in groups, we're all interacting with people, and you've got to have people's skills to be a chemist, and they're surprised about that, but I think that contributes to it. Also, we're data-driven. We know how to analyze data. We know how to synthesize material from various sources and come to a conclusion. I think that's all terrific for someone who has to be in administration to make those decisions. Also, what else do we have to do? We have to write up our experiments and get them published. And to do that, you have to be able to communicate with others. You have to be able to write well. You have to be able to read the literature. And again, put together information from a lot of different sources. And so also there are some mathematical ability or skills, even if it's not much more than arithmetic. You can estimate orders of magnitude. You can think about things. A lot of people, you'd be amazed how many people think I'm smart just because I can do arithmetic in my head, you know. All of those things. And when you tell people that, these skills all come out of chemistry, they're surprised. But this is why I suggested before we might want to think about chemistry as a liberal art. There are so many ways of knowing, so many critical skills that you develop as a result of being a chemist, of doing the science, that are transferable to so many areas of life. And we tend to think, because we're chemists or professors, you know, the real value is if you get someone to go get a PhD. Well, if you get someone to go to be the director of personnel at Monsanto and they have a science background and they're literate and they pass that along, that's a value too. So I think all of the things that bring to bear on chemistry and the study of chemistry makes for good administrators.
I think much of what Chancellor Vandegrift said is relevant to my own circumstance. I had the good fortune of being an experimentalist at a really great research university. I was at MIT for a long time, and I was able to draw together a very large research group. And in having a group of people, more and less junior, and being responsible to them for research support and mentorship and the other things that are expected of a research leader, you almost become the CEO of a small organization. And now it's challenging for us because we have, you know, at our universities, we have scores of CEOs who are in principle supposed to be accountable to us, but
some are in this room, so
they all know best. But I do believe that what's been said is very important to the young people. I would strongly urge you to develop these skills of being able to work with others. I think the experience that PhD students often have in being involved as a teaching assistant, sometimes those are roles that are not celebrated. They're regarded as a chore. But take advantage of that as an opportunity to develop your skill in working effectively with others and helping them realize their potential. Those are very important elements in development. I think there is one difference in what we're doing today compared to what I was doing when I was leading a research group. It's true that in chemistry you can define your experiments very well. Maybe they're unimportant, but once you've done the experiment and you see the result and you can write it up for publication, you can kind of wrap that up. And it's a very rewarding experience to know that the project has been completed and the work has been published. In the work that I'm doing, at least, I can't actually tell whether it's finished or whether it's good or whether it's even something you can discuss, let alone publish. But I find chemistry to be among those fields where you can have a great deal of self-satisfaction by doing chemistry. And it's still the case that in many areas of chemistry, within one building at least, you can do things that no one else has ever done before, and you can be absolutely certain you've done it. And I think that's a really great reason for going into chemistry. There's a lot of definition to a successful undertaking in a chemistry world.
I think we have on the panel 3 illustrious examples of successful chemical scientists, not only in the laboratory but elsewhere. And so I'd like to, before we conclude this session, I know there are other hands up, but out of respect to the schedule of the meeting, I'd like to ask the audience for 3 things. First, I'd like you to join me in thanking the panel for being here with us this afternoon. Thank you very much. Thank you. And then secondly, I'd like to ask you to thank the organizers of this meeting. You know, we're all volunteers, except for John Michael, who's a paid ACS staff member. We're all volunteers here. So I'd like you to also join in thanking the organizers for the wonderful job that they've done. And the third and last thing I'd like to ask you, because I announced this as being some kind of an experiment, just an early feedback from you. What is your reaction to this session?
Great idea.
Can you indicate by some kind of applause of some sort whether it's I have my audio meter here. I got a good reading on that. So, so the future organizer, the organizers of future meetings, think about sessions like this. I'm happy to work with organizers at regional meetings. I think regional meetings are very, very important. The likelihood of getting the 3 panelists to a national meeting is much smaller than it is to having them here today. And the likelihood of your going to a national meeting is not as great. So think about the type of programming. Think about the ACS as a science organization. Think about the ACS as an educational organization. Think about the ACS as a learned society and the responsibilities and the obligations that come along with being a learned society, to explore the kinds of ideas and exchanges that we've had here this afternoon. And I want to thank you, and I want to ask you to pursue the rest of the meeting, and anyone who is inclined to communicate with me, just go to my website, scifund.org, send an email message, and be happy to hear from you. So thank you all very much, and this session is adjourned now.